Okay, so the congruent arcs are going to be arcs formed by two congruent chords. So again, a chord is a segment that connects two endpoints on a circle. So we have two chords here, and let's just say that these two chords are congruent. So they would be marked congruent. And that would mean that the arcs would also be congruent. So arc FG would be congruent to JH. So let's see an example of this. I'll give you a minute to copy this example down. And we'll break it down. It says in circle C, WX, so WX right here is 25 degrees. XY, so XY here is 40 degrees. And YZ is 25 degrees. Then they tell us that WY, the segment, is 24 centimeters. Well, if we kind of separate this circle out, you see that this arc, let's use a highlighter instead, this arc is 25 plus 40 degrees, so 65 degrees. And you'll see that this arc is also 65 degrees. So since the two arcs are congruent, then we can say that the two chords are congruent. So if they told us that WY from here to here is 24 centimeters, then that would mean that XZ is also 24 centimeters because the two arcs are congruent. Okay, the next theorem is the bisecting arcs and chords theorem. And that says that if a radius or a diameter is perpendicular, so here's our perpendicular, to a chord, then it bisects the chord. So in other words, it's going to cut this chord into two equal pieces. So XZ would be congruent to ZY. So here's an example where TV is a diameter, and we can see that because there's the center right there of the circle. So what is the value of X? Well, if you look, we have a diameter perpendicular to a chord, which means that the chord is cut into two equal pieces, or two congruent pieces. So if the length of S to this point is 8, then the length of this point to U is also 8. So X in this picture would be 8. Very easy. This 10 right here, that's actually the radius, but that's worthless. We don't need that information when we have the bisecting arcs and chord theorem. Okay, your next study question, what is the parallel chords theorem? And that says that if two chords are parallel, then the arcs they intercept are congruent. So let's go ahead and mark CD parallel to AB. So if CD is parallel to AB, then the arcs that they intercept are congruent. So DA, arc DA would be congruent to arc CB. Okay, let's go ahead and get this example down. Make sure when you make your two chords, one of them is a diameter, that they appear to be parallel. So it says TW is a diameter of circle X, and TW is also parallel to UV. So automatically, I'm not even going to finish reading the question. I know, based on the fact that these two segments are parallel, I know that these two arcs are congruent. So I can mark this as 25 degrees. and that's the parallel chords theorem. Now if I finish reading the question, it says, if the measure of TU is 25, what is the degree measure of UV? So I'm actually not looking for WV, I'm looking for UV. But if you notice that TW is a diameter and splits the circle in half. And we know that half a circle is 180 degrees. So from T all the way to W is 180 degrees. And we've already used TU, 25 degrees, so we'll subtract that away from 180. And we've already used WV, another 25 degrees. So the remainder, 180 minus 50 total, is 130. So that's what arc UV is equal to, 130 degrees. Okay, and the last theorem that we're going to do is the inscribed angle theorem. We talked before about central angles, and that's how we were able to find the measure of the arc. Now we have the inscribed angle theorem, and that says the measure of an inscribed angle is half the measure of its intercepted arc. So take a minute, go ahead and cut out 3 circles and label them as such. 100 degrees for circle P, 60 degrees for this angle in circle P, and 20 degrees for the inscribed angle with X on the exterior of the circle. So if you notice, these are all inscribed angles, meaning the vertex of the angles is on the circle. And the inscribed angle is half the measure of the intercepted arc. So if you're starting on the outside of the circle, the inscribed angle is half of the arc. So the inscribed angle here would be 50 degrees, half of 100. But if you go from the inside of the circle out, you multiply by 2, or the inscribed angle times 2 will equal the arc. So 120 for this arc. So then what do you think the X value would be for this inscribed angle's intercepted arc? Okay, it would be double, so multiply 20 times 2, so it would be 40 degrees. Okay, so in this example, we want to find the measure of angle DAR. So if we figure out arc DR, the central angle, because DAR is a central angle, the central angle will equal the arc. So originally we're given an inscribed angle, and the inscribed angle times 2 gives you the arc that it intercepts. So 68. And angle DAR is a central angle, so it equals the arc. So the measure of angle DAR is equal to 68 degrees.